Displacement time graphs. A displacement time graph is one way of representing the motion of an object. The displacement is represented on the vertical axis and the time on the horizontal axis. Displacement is often represented as the distance from some fixed point O. So here we have the displacement in meters and the time in seconds in this particular case. We should note that in the case of an object moving back and forth along a line, such as this, where O is somewhere here, we would consider one side of O to be positive, usually the right-hand side, and the other negative. In this case, we would need to have displacement having both above the axis, i.e. positive, and below the axis, i.e. negative displacements. If we have an object that does something like this, then the displacement time graph might look something like this. The gradient of a displacement time graph indicates the velocity of the object. So if we just have a horizontal, in other words, the displacement or distance from a position isn't changing, then we can say the velocity is 0. And the gradient is 0. And we said up here that the gradient of a displacement time graph indicates the velocity of the object. If we have a line like this, where we can see that the displacement is changing steadily with respect to time, the displacement is increasing at a steady rate, and so the velocity is constant. And we know that straight lines have a constant gradient, so that all fits together nicely. Another situation we might have is something like this. Now I'll explain the lines I'm putting on here momentarily, but I'm just going to put the lines on for now. The displacement is increasing. Yes, we can see that it was increasing in the last one, but the rate at which it's increasing is changing in this one. As time goes on, greater distances are covered in the same time. So that's with these lines. This time interval here and this time interval are different. But if we look at the change in displacement, it's much larger here because the object is traveling more quickly. And we can see that because of the steeper gradient up here compared to down here. So the conclusion we would draw from this is that the object is accelerating. The gradient of the curve is increasing, therefore the velocity is increasing, so the object is accelerating. Velocity is the rate of change of displacement. Average velocity is the displacement from the starting point divided by the time taken. The average speed is the total distance travelled divided by time taken. And we'll look at the difference between these two in one of the examples that follows.